Of the many eruptions of Mount Vesuvius, a major stratovolcano in southern Italy, the best known is its eruption in 79 AD, which was one of the deadliest and best known in European history. In autumn of 79 AD, Mount Vesuvius violently spewed forth a deadly cloud of superheated tephra and gases to a height of 33 km, 21 mi, ejecting molten rock, pulverized pumice, and hot ash at 1.5 million tons per second, ultimately releasing 100,000 times the thermal energy of the atomic bombings of Hiroshima and Nagasaki. The event gives its name to the Vesuvian type of volcanic eruption, characterized by columns of hot gases and ash reaching the stratosphere, although the event also included pyroclastic flows associated with Pelian eruptions. The event destroyed several towns and minor settlements in the area, at the time part of the Roman Empire. Pompeii and Herculaneum, obliterated and buried underneath massive pyroclastic surges and ashfall deposits, are the most famous examples. After archaeological excavations revealed much about the lives of the inhabitants, the area became a major tourist attraction and is now a UNESCO World Heritage Site and part of Vesuvius National Park. The total population of both cities was over 20,000. The remains of over 1,500 people have been found at Pompeii and Herculaneum so far, although the total death toll from the eruption remains unknown. A major earthquake caused widespread destruction around the Bay of Naples, particularly to Pompeii on February 562 AD. Some of the damage had still not been repaired when the volcano erupted in 79 AD. Another smaller earthquake took place in 64 AD. It was recorded by Suetonius in his biography of Nero, and by Tacitus and Annales because it took place while Nero was in Naples performing for the first time in public theater. Suetonius recorded that the emperor continued singing through the earthquake until he had finished his song, while Tacitus wrote that the theater collapsed shortly after being evacuated. Minor earthquakes were reported in the 4 days before the 79 AD eruption, but the warnings were not recognized. The inhabitants of the area surrounding Mount Vesuvius had been accustomed to minor tremors in the region. Pliny the Younger wrote that they were not particularly alarming because they are frequent in Campania. Reconstructions of the eruption and its effects vary considerably in the details but have the same overall features. The eruption lasted for 2 days. Pliny the Younger, author of the only surviving written testimony, described the morning before the eruption as normal. However, he was staying at Misenum, 29 kilometers, 18 mi, from the volcano across the Bay of Naples, and may not have noticed the early signs of the eruption. During the next 2 days, he did not have any opportunity to talk to people who had witnessed the eruption from Pompeii or Herculaneum. He never mentioned Pompeii in his letter. Around 1:00 p.m., Mount Vesuvius erupted violently, spewing up a high-altitude column from which ash and pumice began to fall, blanketing the area. Rescues and escapes occurred during this time. At some time in the night or early the next day, pyroclastic flows in the close vicinity of the volcano began. Lights seen on the mountain were interpreted as fires. People as far away as Misenum fled for their lives. The flows were rapid, moving, dense, and very hot, wholly or partly knocking down all structures in their path, incinerating or suffocating the remaining population, and altering the landscape, including the coastline. These were accompanied by additional tremors and a mild tsunami in the Bay of Naples. One or more earthquakes at this time were strong enough to cause buildings to collapse, at least in Pompeii, killing the occupants. By the evening of the second day, the eruption was over, leaving only haze in the atmosphere, screening sunlight. Pliny the Younger wrote, "Broad flames shone out in several places from Mount Vesuvius, which the darkness of the night contributed to render still brighter and clearer. It was now day everywhere else, but there a deeper darkness prevailed than in the thickest night." Sigurdsson, Cashdollar, and Sparks undertook a detailed stratigraphic study of ash layers based on excavations and surveys, published in 1982. They concluded that the eruption unfolded in 2 phases, Vesuvian and Pelian, which alternated 6 times. A first Plinian phase projected a column of volcanic debris and hot gases between 15 chem 9 mi and 30 chem 19 mi and 30 chem 19 mi, into the stratosphere. This phase lasted 18 to 20 hours and spread pumice and ashes, forming a 2.8 em9f2 layer to the south towards Pompeii. An earthquake caused buildings in Pompeii to collapse at this time. The following Pelian phase produced pyroclastic surges of molten rock and hot gases that reached as far as Misenum to the west. Concentrated to the south and southeast, two pyroclastic surges engulfed Pompeii with a 1.8 meter deep 6ft layer, burning and asphyxiating any living beings who had remained behind. Herculaneum and Oplontis received the brunt of the surges and were buried in fine pyroclastic deposits, pulverized pumice and lava fragments up to 20 m 70 feet deep. Surges 4 and 5 are believed to have destroyed and buried Pompeii. Surges are identified in the deposits by Dunn-and-Cross bedding formations, which are not produced by fallout. The eruption is considered primarily phreatomagmatic, i.e., a blast driven by energy from escaping steam produced by seawater seeping into the deep-seated faults and interacting with hot magma. In an article published in 2002, Sigurdsson and Casey concluded that an early explosion produced a column of ash and pumice which rained on Pompeii to the southeast, but not on Herculaneum, which was upwind. Subsequently, the cloud collapsed as the gases densified and lost their capability to support their solid contents. The authors suggest that the first ash falls are to be interpreted as early morning low-volume explosions not seen from Misenum, causing Rectina to send her messenger on a ride of several hours around the Bay of Naples, then passable, providing an answer to the paradox of how the messenger might miraculously appear at Pliny's villa so shortly after a distant eruption that would have prevented him. A 2006 study by Zanella, Gurioli, Peresci, and Lanza used the magnetic characteristics of over 200 samples of lithic, roof tile, and plaster fragments collected from pyroclastic deposits in and around Pompeii to estimate the equilibrium temperatures of the deposits. The deposits were placed by pyroclastic density currents, PDCs, resulting from the collapses of the Plinian column. The authors argue that fragments over 25 km 0.82 in were not in the current long enough to acquire its temperature, which would have been much higher. Therefore, they distinguished between the depositional temperatures, which they estimated, and the emplacement temperatures, which in some cases, based on the cooling characteristics of some types and fragment sizes of rocks, they believed they also could estimate. The final figures are considered to be those of the rocks in the current just before deposition. All crystal rock contains some iron or iron compounds, rendering it ferromagnetic, as do Roman roof tiles and plaster. These materials may acquire a residual field from several sources. When individual molecules, which are magnetic dipoles, are held in alignment by being bound in a crystalline structure, the small fields reinforce each other to form the rock's residual field. Heating the material adds internal energy to it. At the Curie temperature, the vibration of the molecules is sufficient to disrupt the alignment. The material loses its residual magnetism and assumes whatever magnetic field might be applied to it only for the duration of the application. The authors term this phenomenon unblocking. Residual magnetism is considered to block out non-residual fields. A rock is a mixture of minerals, each with its own Curie temperature. The authors therefore looked for a spectrum of temperatures rather than a single temperature. In the ideal sample, the PDC did not raise the temperature of the fragment beyond the highest blocking temperature. Some constituent materials retained the magnetism the Earth's field imposed when the item was formed. The temperature was raised above the lowest blocking temperature. Therefore, some minerals on recooling acquired the magnetism of the Earth as it was in 79 AD. The broad field of the sample was the vector sum of the fields of the high blocking material and the low blocking material. This type of sample made it possible to estimate the low unblocking temperature. Using special equipment that measured field direction and strength at various temperatures, the experimenters raised the temperature of the sample in increments of 40 dec 70 def, from 100 dec 70 def, from 100 dec 210 def, until it reached the low unblocking temperature. Deprived of one of its components, The overall field changed direction. A plot of direction at each increment identified the increment at which the sample's resultant magnetism had formed. That was considered the equilibrium temperature of the deposit. Considering the data for all the surge deposits arrived at a surge deposit estimate. The authors discovered that the city of Pompeii was a relatively cool spot within a much hotter field, which they attributed to the interaction of the surge with the fabric of the city. The investigators reconstruct the sequence of volcanic events as follows. On the first day of the eruption, a fall of white pumice containing clastic fragments of up to 3 centimeters, 1 in, fell for several hours. It heated the roof tiles to 120, 140 dsec, 250, 280 dec. This period would have been the last opportunity to escape. Subsequently, a second column deposited a gray pumice with clastics up to 10 km 4 in temperature unsampled, but presumed to be higher, for 18 hours. These two falls were the Plinian phase. The collapse of the edges of these clouds generated the first dilute PDCs, which must have been devastating to Herculaneum, but did not enter Pompeii. Early in the second morning, the gray cloud began to collapse to a greater degree. Two major surges struck and destroyed Pompeii. Herculaneum and all its population no longer existed. The emplacement temperature range of the first surge was 180-220 deg EC, 360-430 def. Minimum temperatures of the second 220-260 DC, 430-530-500 def. The depositional temperature of the first was 140-300 dex, 200-500 ventured T100 deci. Upstream and downstream of the flow, it was 300-360 DC, 570-680 dic. The variable temperature of the first surge was due to interaction with the buildings. Any population remaining in structural refuges could not have escaped, as gases of incinerating temperatures surrounded the city. The lowest temperatures were in rooms under collapsed roofs. These were as low as 100 deg 212 dave, the boiling point of water. The authors suggest that elements of the bottom of the flow were decoupled from the main flow by topographic irregularities and made cooler by introducing turbulent ambient air. In the second surge, the irregularities were gone, and the city was as hot as the surrounding environment. During the last surge, which was very dilute, an additional 1 meter, 3.3 ft of deposits fell over the region. The only surviving eyewitness account of the event consists of 2 letters by Pliny the Younger, who was 17 at the time of the eruption, to the historian Tacitus, and written some 25 years after the event. Observing the first volcanic activity from Misenum across the Bay of Naples from the volcano, approximately 29 kilometers, 18 mi, away, Pliny the Elder, Pliny the Younger's uncle, launched a rescue fleet and went himself to the rescue fleet and went himself to the rescue of a personal friend. His nephew declined to join the party. One of the nephew's letters relates what he could discover from witnesses of his uncle's experiences. In a second letter, the younger Pliny details his own observations after the departure of his uncle. Pliny the Younger saw an extraordinarily dense cloud rising rapidly above the mountain, the appearance of which I cannot give you a more exact description of than by likening it to that of a pine tree, for it shot up to a great height in the form of a very tall trunk, which spread itself out at the top into a sort of branches. It appeared sometimes bright and sometimes dark and spotted, according as it was either more or less impregnated with earth and cinders. These events and a request by messenger for an evacuation by sea prompted the elder Pliny to order rescue operations in which he sailed away to participate. His nephew attempted to resume a normal life, continuing to study and bathe, but that night a tremor woke him and his mother, prompting them to abandon the house for the courtyard. At another tremor at dawn, the population abandoned the village. After a third tremor, the sea seemed to roll back upon itself and to be driven from its banks, which is evidence of a tsunami. There is, however, no evidence of extensive damage from wave action. A black cloud obscured the early light, through which shone flashes, which Pliny likens to sheet lightning, but more extensive. The cloud obscured Point Misenum near at hand and the island of Capri, across the bay. Fearing for their lives, The population began calling each other and moving back from the coast along the road. Pliny's mother requested him to abandon her and save his own life, as she was too fleshy in age to go further, but seizing her hand, he led her away as best he could. A rain of ash fell. Pliny needed to shake off the ash periodically to avoid being buried. Later that same day, the ash stopped falling and the sun shone weakly through the cloud, encouraging Pliny and his mother to return home and wait for news of Pliny the Elder. The letter compares the ash to a blanket of snow. The earthquake and tsunami damage at that location were not severe enough to prevent continued use of the home. Pliny's uncle, Pliny the Elder, was in command of the Roman fleet at Misenum, and had meanwhile decided to investigate the phenomenon at close hand in a light vessel. As the ship was preparing to leave the area, a messenger came from his friend Rectina, wife of Bacchus, living on the coast near the foot of the volcano, explaining that her party could only get away by sea, and asking for rescue. Pliny ordered the immediate launching of the fleet galleys to the evacuation of the coast. He continued in his light ship to the rescue of Rectina's party. He set off across the bay, but encountered thick showers of hot cinders, lumps of pumice, and pieces of rock in the shallows on the other side. Advised by the helmsman to turn back, he stated fortune favors the brave and ordered him to continue to Stabia, about 4.5 km or 2.8 mi from Pompeii, where Pomponius was. Pomponianus had already loaded a ship with possessions and was preparing to leave, but the same onshore wind that brought Pliny's ship to the location had prevented anyone from leaving. Pliny and his party saw flames coming from several parts of the mountain, which Pliny and his friends attributed to burning villages. After staying overnight, the party was driven from the building by its violent shaking. They woke Pliny, who had been napping and snoring loudly. They elected to take to the fields with pillows tied to their heads to protect them from rockfall. They approached the beach again, but the wind had not changed. Pliny sat down on a sail spread for him and could not rise, even with assistance. His friends then departed, escaping ultimately by land. Very likely, he had collapsed and died, the most popular explanation for why his friends abandoned him, although Suetonius offers an alternative story of his ordering a slave to kill him to avoid the pain of incineration. How the slave would have escaped remains a mystery. There is no mention of such an event in his nephew's letters. In the first letter to Tacitus, his nephew suggested that his death was due to the reaction of his weak lungs to a cloud of poisonous sulfurous gas that wafted over the group. However, Stabiae was 16 chem 9.9 mi from the vent, roughly where the modern town of Castellamare di Stabia is situated, and his companions were apparently unaffected by the fumes, and so it is more likely that the corpulent Pliny died from some other cause, such as a stroke or heart attack. An asthmatic attack is also not out of the question. His body was found with no apparent injuries the next day once the plume had dispersed. Apart from Pliny the Elder, the only other notable casualties of the eruption to be known by name were the Herodian Edomite princess Drusilla and her son Agrippa, who was born in her marriage with the procurator Antonius Felix. It is also said that the poet Caesius Bassus died in the eruption. By 2003, approximately 1044 casts made from impressions of bodies in the ash deposits had been recovered in and around Pompeii, with the scattered bones of another 100. The remains of about 332 bodies have been found at Herculaneum, 300 in arched vaults discovered in 1980. The total number of fatalities remains unknown. 38% of the 1044 were found in the ashfall deposits, the majority inside buildings. This differs from modern experience over the last 400 years, when ashfalls have killed only around fourths of victims during explosive eruptions. This cohort was possibly sheltering in buildings when they were overcome. The remaining 62 of bodies found at Pompeii lay in the pyroclastic surge deposits, which probably killed them. It was initially believed that due to the state of the bodies found at Pompeii and the outline of clothes on the bodies, it was unlikely that high temperatures were a significant cause. Later studies indicated that during the fourth pyroclastic surge, the first surge to reach Pompeii, the temperature reached 300 DC 500 dec, 572 def, which was enough to kill people in a fraction of a second. The contorted postures of bodies as if frozen in suspended action were not the effects of long agony, but of the cadaveric spasm, a consequence of heat shock on corpses. The heat was so intense that organs and blood were vaporized, and at least one victim's brain was vitrified by the temperature. Herculaneum, which was much closer to the crater, was saved from Tephra Falls by the wind direction, but was buried under 23 meters. 75 ft of material deposited by pyroclastic surges. It is likely that most or all of the known victims in this town were killed by the surges, particularly given evidence of high temperatures found on the skeletons of the victims found in the arched vaults on the seashore and the existence of carbonized wood in many of the buildings. These people were concentrated in the vaults at a density as high as 3 per square meter and were all caught by the first surge, dying of thermal shock and partly carbonized by later and hotter surges. The vaults were most likely boathouses, as the crossbeams overhead were probably for the suspension of boats used for the earlier escape of some of the population. As only 85 meters, 279 feet of the coast have been excavated, more casualties may be waiting to be unearthed. Vesuvius and its destructive eruption are mentioned in 1st century Roman sources, but not the day of the eruption. For example, Josephus in his Antiquities of the Jews mentions that the eruption occurred in the days of Titus Caesar. Suetonius, a 2nd century historian, in his Life of Titus simply says that there were some dreadful disasters during his reign, such as the eruption of Mount Vesuvius in Campania. Writing well over a century after the actual event, Roman historian Cassius Dio, as translated in the Loeb Classical Library 1925 edition, wrote that in Campania remarkable and frightful occurrences took place. For a great fire suddenly flared up at the very end of the summer, for more than 5 centuries, until approximately 2018, articles about the eruption of Vesuvius typically stated that the eruption began on August 24 of 79 AD. This date came from a 1508 printed copy of a letter addressed by Pliny the Younger to the Roman historian Tacitus, originally written some 25 years after the event. Pliny was a witness to the eruption and provided the only known eyewitness account. Over 14 centuries of manuscript hand copying up to the 1508 printing of his letters, the date given in Pliny's original letter may have been corrupted. Manuscript experts believe that the date originally given by Pliny was one of August 24, October 30, November 1, or November 23. This odd scattered set of dates is due to the Romans' convention for describing calendar dates. The large majority of extant medieval manuscript copies, there are no surviving Roman copies, indicate a date corresponding to August 24. Since the discovery of the cities, this was accepted by most scholars and by nearly all books written about Pompeii and Herculaneum for the general public. Since at least the late 18th century, a minority among archaeologists and other scientists have suggested that the eruption began after August 24 during the autumn, perhaps in October or November. In 1797, the researcher Carlo Rossini reported that excavations at Pompeii and Herculaneum had uncovered traces of fruits and braziers indicative of autumn, not the summer. More recently, in 1990 and 2001, archaeologists discovered more remnants of autumnal fruits, such as the pomegranate. The remains of victims of the eruption in heavy clothing and large earthenware storage vessels laden with wine at the time of their burial by Vesuvius. The wine-related discovery suggests that the eruption might have happened after the grape harvest. In 2007, a study of prevailing winds in Campania showed that the southeasterly debris pattern of the 1st century eruption is quite consistent with an autumn event, and inconsistent with an autumn event, and inconsistent with an August. Date. During June, July, and August, the prevailing winds flow to the west, an arc between the southwest and northwest virtually all the time. As Emperor Titus of the Flavian dynasty, reigning June 24, 79 to September 13, 81, garnered victories on the battlefield, including his capture of the Temple of Jerusalem. And other honors, his administration issued coins enumerating his ever-growing accolades. Given the limited space on each coin, his achievements were stamped on the coins using an arcane encoding. 2 of these coins from early in Titus's reign were found in a hoard recovered at Pompey's House of the Golden Bracelet. Although the coins' minting dates are somewhat in dispute, a numismatic expert at the British Museum, Richard Abdy, concluded that the latest coin in the hoard was minted on or after June 24, the first date of Titus' reign. and before September 1 of 79 AD. Abdi states that it is remarkable that both coins will have taken just 2 months after minting to enter circulation and reach Pompeii before the disaster. In October 2018, Italian archaeologists uncovered a charcoal inscription reading the 16th day before the calends of November, dated October 17 of 79 AD, as it was unlikely to have been a year old, which sets the earliest possible date for the eruption. A collaborative study in 2022 has determined a date of October 24, 25